Students, good morning. Today we are talking about that new chapter. So that is chemical bonding and molecular structure. Yesterday I gave a clue. That means note for you. Today, actually, I said to you today we are talking about that chemical bonding chapter. Students, listen. So this is the very important chapter for us. Atomic structure, periodic classification, and next one is the top the chapter, that is the chemical bonding and molecular structure. So up to here we have completed that is we have completed that chapter. First one is the atomic structure already over in our school times. That means next one is the this is also over now that periodic classification. So I will complete that the chapter within this month. Actually, it is the very biggest chapter. The chemical bonding chapter is really communicated with all chapters actually. Physical, inorganic, and next with the organic concept wise. Here, students, now the chemical bonding and next with the molecular structures. Chemical bonding and molecular structure. So first of all, now the chemical bonding and molecular structure is completely depends upon that periodic classification. So in periodic classification we have learnt more things: lattice enthalpy, hydration enthalpy, solvation process, ionization potential, electronegativity, electron affinity character. So such type of properties, such type of concepts we have covered in that chapter. So though, based on that, related with those concepts, we should cover that new concept in this chapter. So first of all, what is meant by chemical bonding? Why do chemical bonding takes place? Why do atoms combine to form? So this is the one type of questions. Of course, some atoms are combined to form a molecules. So that is the one type of attractive forces are operating in between that atoms. But what is the reason? Few elements does not undergo any bond formation. What happens here? Few elements does not undergo chemical bonding. But few elements undergo chemical bonding. What happens here? Both are the atoms and both are the elements. But here, such type of reactions does not take place in between the atoms. So these are the different type of questions for completing to give that answer. And here, in the entire periodic table, we know some elements are stable and few elements are not stable in nature. So what is the stability factor? What is the relation with that stability of the elements and the bond formation? Why do we are talking about those things here? Okay, students. Now that means the total questions for these all type of questions we should give that we should clarify that answers for those questions. Now actually that will be depends upon that chemical reaction, that will depends upon the rate of reaction, or that will be depends upon that stability. For example, students, we know in our daily life, if we want to reach something, we are always we are vigorously working to get that thing. For example, if you want to get one thing, so you are ready to always trying to get that. After getting that thing, you are not ready to do further work. So when we got something, then we think about that one, we are realized. So that means now that leads to the decreasing the energy. So this is the one of the property. So that means the chemical bond should be takes place for the decreasing the energy. So this is the one of the concept. Cause for the chemical bonding. Cause for the chemical bonding. So cause for the chemical bonding, that means you should give the answer to decreasing their energy. In this one, in chemistry, in our periodic table, elements are always possessing more energies. So more energy means less stability. Now the molecules are greater stable, that means they possess less energy. After bond forming, that means after bond formation, atoms are combined to form a molecule. So when do we get molecules? Now the molecules release some amount of energy, that means less energy means more stable. So this is one of the concept. So purpose of, for the sake of least energy, more stability. Okay students, so this is the one concept. And the second concept is that octet rule or octet configuration. Students, we know according to periodic classification, octet rule, the atom which have 8 electrons in the outermost orbital, the atom should get the more stability. Which element has 8 electrons in the outermost orbital? Which atom should have having 8 electrons in that outermost orbital? So those are at a stable configuration. So for the stability purpose, atoms should gain the electrons, should lose the electrons, and share the electrons and donate the electrons. So by conducting these type of process, by proceeding these type of process, finally the ultimate thing of the chemical body should get a stability. Stability should, that means the atom should get stability by loss of electron. Atoms get stability by gaining of electron, by sharing of electron, by donation of electron, by contribution of electron. So these are the general properties to get the stability. So I hope you understood the chemical bonding is takes place for the stability. Okay students, atoms are always unstable, molecules are always stable. So due to stability, the atom should participate in the bond formation to get the more stable. So each and every atom in the entire periodic table except noble gas elements, they are ready, they are all except noble gas elements, they are always ready to get the stable configuration. So that is the octet rule. Okay students, now here based on that rules, now the atom should be participating in the chemical bonding, they to get stability. So this is the most important reasons for this. And one next question. So what type of forces are operating in between the atoms? Okay students, generally now the atoms are holds together. Generally the atoms are attached to each other. So what type of, that means which type of forces are operating in between the atoms? Now especially in electrostatic force of attraction is operating in between the two constituent atoms. Okay students, electrostatic force of attraction is operating in between the two constituent atoms. So this is the first thing. Okay students, now when the two atoms are holds together, held together, due to those two atoms are having electrostatic force of attraction in between the constituent atoms. So that's why two atoms or two ions or two molecules are held together by the electrostatic force of attraction. Now that force is called as a chemical bonding. Okay students, now that force is called as a chemical bonding. So this is the most important concept to proceed chemical bonding are the cause of the chemical bonding. Okay students, now we are in that concept. Okay, now that electrostatic force of attraction is operating in between the two constituent atoms, now the type of force is called as a chemical bonding. Okay students, But here our topic is the chemical bonding and next the molecular structure. So what is the related to that molecular structure? That means how do atoms combine to form a molecules, and what is the shape of that molecule, and what is the geometry of the molecule. Now here I hope maybe I will give them each and every concept in simple manner and a detailed manner. Why? Because it has the very very large biggest chapter in the total chemistry. It gives the complete support for that I am organic chemistry, inorganic chemistry, next in the physical chemistry. You should remember that thing, students. Really. Okay. Now here types of chemical bonds. Now actually types of chemical bonds means what type of chemical bonds are takes place here. Okay, students. Now if we are talking of the talking about the types of chemical bonds, now here if the bond formation should be takes place within the atoms. Okay, and if the bond formation should be takes place in between the molecule. So especially the chemical bonds are takes place in the two, that is chemical bonding undergoes the two types of bond formation majorly or mainly. Okay, students. And now first one is the interatomic bond formation, and next one is the intermolecular bond formation. Okay, students. First one is the interatomic bond formation, and next one is the of intermolecular bond formation. Okay, students. I hope I wrote here. Now the types of chemical bonding. First one is the interatomic chemical bonding, and next one is the intermolecular chemical bond. Listen, students. Here we have the two other different words. Interatomic chemical bonding, intermolecular chemical bonding. First of all, the molecule atom means atom has that electrons, protons, and next in the neutrons. You know that thing. Okay, no? Molecules means number of atoms combined to form a molecule. In that molecules undergoes the attraction, atoms undergoes the top attraction. So here the interatomic means attraction takes place in between the atoms. Okay, intermolecular means molecules, larger molecules undergoes the bond formation. So which one has the greater strength? Which bonds are the stronger bonds? How many types of bonds should be takes place in between the top atomic, that means interatomic bond formation, and next one is the intermolecular bond formation. Okay, students. Now, for example, you should think one thing. You should think one object. If you take the smallest particle, then what happens in always the smaller particles or the smaller atom which has the larger attraction in between that one. Already I said to you that I covered some number of times. Now that is the intermolecular forces and the intermolecular system. So distance and force. That means in this case we should study about the Coulombic force. Coulombic force means K is equal to Q1 by K is equal to F into Q1 Q2 by R square. That means distance in between that electrostatic force of attraction. That means now two types of forces are operating in that one. Now that is the what about this one? Now here now first force is the top centrifugal force, and next the centripetal forces are operating here. Centrifugal and next the centripetal force. So centrifugal and centripetal force, if we are talking about these concepts, centrifugal and centripetal force means electrons are attracted towards the nucleus and electrons are away from the nucleus. So what a wonderful word here. Okay, you think about that or no? So that means electrons are attracted towards the nucleus. This is the what type of attraction. Electrons are away from the nucleus. Generally, electrons always should attract with that nucleus, but here the type of phenomenon does not take place. So this is the another concept student here. Okay, so that's why you should think when I am talking about the subject, you are always listen carefully what type of concepts I covered here. Okay, students. So that is the most important thing here. Now the reason, so once again, types of chemical bonding, interatomic chemical bonding, and next one the intermolecular chemical bonding. So the bond formation takes place in between the atoms. Now such type of bond formation called as interatomic bond formation. Interatomic bond formation is the stronger bonds, and intermolecular bonds are that weaker bonds. Okay, friends. Intermolecular bonds are that very weak bonds. Okay, but the intermolecular bonds are that weaker bonds. Interatomic bonds are the very stronger bonds. Now here it has them, it releases them or it requires them greater energy. High bond energy is required, or high bond energy is released. Now in case of interatomic bond formation, less bond is required, less bond is released in case of intermolecular forces. Okay, results. So these are the types of chemical bonding. First one is the interatomic bond formation, and the second one is the intermolecular bond formation. So if we see about one by one in case of interatomic bond formation. So here if you take that one is the types of interatomic bond formation. What type of interatomic bond formation takes place in the atoms? What type of intermolecular bond formation takes place? What type of intermolecular bond formation takes place in the second category? Okay, students. First of all, if we are talking about this one, in case of interatomic bond formation, first one is the ionic bond formation. Okay, students. First one is the ionic bond formation, and next one is the top covalent bond formation, and next one is the coordinate covalent bond formation, and next one is the metallic bond formation. Okay, students. Now here, in between the atoms, ionic type of bond should be takes place. Covalent bond formation takes place in between the atoms, and next one the coordinate bond formation takes place in between the atoms, and metallic bonding should be takes place in between the atoms. Actually here, now the coordinate bond is also example for the top covalent bond formation. Okay, students. Now here ionic bonding. Okay, next one the covalent bonding, and next one is the coordinate covalent bonding, and next one is the metallic bonding. Okay, so these are the types of bond formation which which bonds are takes place in the term atoms. And next one is the term intermolecular bond formation. Now here intermolecular bond formations are the very weak bonds, comparing with that these type of bonds. It means ionic covalent and coordinate covalent and metallic like bond. Okay. So these are the stronger bonds, and these are the weaker bonds. Okay. Now here once again intermolecular bond formation is again classified the number of times. Now first one is that van der Waals force of attraction. Okay, so it's van der Waals force of attraction. Now van der Waals force are the very weak forces. Now such type of forces are operating in between the non-bonding atoms or in between the molecules. Okay, students. Van der Waals force of attraction is operating in between the non-bonding atoms, in between the non-bonding molecules, and next one is especially such type of forces are appear are present, or we will see in that okay, zero group elements. Okay, students. Helium, neon, argon, krypton, radon, xenon. Okay, agonization. Helium, neon, argon, krypton, xenon, radon, agonization. So these are the noble gas elements. If we see the force of attraction in the noble gas elements, only now that is intermolecular force. Sorry, now that is only van der Waals forces are operating in that one. Okay, students. But here we have the types of van der Waals force. Okay, students. Now in case of van der Waals force, we have the actually 5 types like that. Number of types are there. Now that is the dipole force, and it's the dipole force are maybe in now that is London forces. Okay, students. Now the first type of that van der Waals force are the dipole forces, and next the London force. And the second one is the dipole forces. Okay, now students, dipole forces, and next one is the dipole induced dipole forces. Okay, students. First one is that in case of van der Waals forces, we have the types. Now the first type is the dipole force, or next the London forces, and next category is the dipole forces, and the third one is the dipole induced dipole forces, Okay, students. So these are the three types are especially present in the van der Waals forces, and the second type is the hydrogen bonding. Okay, students, hydrogen bonding. So here also same thing in case of hydrogen bonding, we have the two types. One is the interatomic that means intermolecular hydrogen bonding, and next one is the intramolecular hydrogen bonding. Okay, students. Students, listen. You should separate. That means you should differentiate the words. Now that one, the first one the intra, and next one is the top intermolecular. Okay, students. Intramolecular means the bond formation takes place within the atoms. The bond formation takes place. Okay, within the atom. Now that means within the molecule. Now that is that intramolecular hydrogen bonding. Hydrogen bonding should be takes place in within the atom or within the molecule. Hydrogen bonding takes place within the molecule, that is called as intramolecular hydrogen bonding, and intermolecular hydrogen bonding means the hydrogen bonding is takes place in between the molecules. Okay, friends, in between the molecules. So this is the second type of hydrogen bonding. Okay, now here after completion of these bonds, next one is that so we have the another different type of new concepts are present. That means allotted in this portion now, that is lattice energy, and next in the hydration energy. Okay, friends. And next one is that in case of lattice energy, we should study about that Born-Haber and Born-Haber cycle. And next one the VBT theory, valency bond theory, and next one the Vesper theory, valence shell electron pair repulsion theory. Okay, friends. Valence shell electron pair repulsion theory. Okay, and next one is that molecular orbital theory. Okay, friends. Now the MOT means molecular orbitals theory. Okay, and next one is the sigma bond formation, and next is the pi bond formation. Okay, friends. Now that means sigma bond formation means end-on and overlapping and axial overlapping. So axial overlapping leads to the top sigma bond formation, and lateral overlapping leads to the top of pi bond formation. Okay. Now the lateral overlapping is also known as the lateral overlapping is also known as the sidewise overlapping or sideway overlapping. And next one is the top hybridization. Okay, students. In 10th portion I have completed about the hybridization. Okay, then now in case of hybridization, intermixing of atomic orbitals combined to form the same number equal number of new set of hybridized orbitals which are having the same energy and the same size and the same geometry. Okay, students. Now the hybridization means due to the involvement of that s orbital, p orbital, d orbital. If the involvement of s and p orbital, it undergoes the top of three types of hybridization: sp hybridization, sp2 hybridization, and sp3 hybridization. Okay, and the involvement of sp and the d orbital. Now that is the first one is that sp3. Okay, next in the first here sp and sp2, and next in the sp3. So including d orbital here, I got mistake. I did a mistake here. So sp and next in the d, sp3d, and next in the sp3d2, and next one is the sp3d3. Okay. So these types of hybridization takes place in that concept. 1, 2, 3, 4, 5, 6. Okay. Now these hybridization explain about that complex molecules. Okay, friends, complex formation molecules. Okay. Now these are the very important concepts. And here now I will start that one. In case of atomic molecule, that means type first type of, that means interatomic bond formation. So you will take that homonuclear diatomic molecules, and next one is the heteronuclear diatomic molecules. Okay, students. Now here polynuclear, that means homonuclear diatomic molecules, heteronuclear diatomic molecules, homonuclear polyatomic molecules, and heteronuclear polyatomic molecules. Okay, students. Now actually Homonuclear means the same kind of nucleus. Okay, friends. Homonuclear means same kind of nucleus. Heteronuclear means different kind of atoms. The nucleus of two atoms, nucleus of different atoms. So that is the heteronuclear diatomic molecules. Okay, friends. For example, I will give that in case of homonuclear means okay, homonuclear diatomic molecules means Cl2 molecule, Br2 molecule, N2 molecule, O2 molecule, and F2 molecule. Okay. Now in case of Cl2, same type of chlorine atoms. In case of Br2, same kind of atoms. In case of N2, same kind of atoms. In case of O2, same type of atoms. In case of F2, same type of atoms. So that's why the homonuclear, the nucleus of two atoms are same. Okay. Homonuclear diatomic molecules, and next one is the top heteronuclear diatomic molecules. Okay, friends. Heteronuclear diatomic molecules. Okay. So heteronuclear diatomic molecules means in case of heteronuclear diatomic molecules, okay, students. Now here hetero means carbon monoxide, nitric oxide. Okay, and next in the this one and HCl, and next one the HBr. Now here you should observe here carbon and oxygen, nitrogen and oxygen, carbon and sulfur, hydrogen and chlorine, and hydrogen and bromine. Okay. So carbon different element with that oxygen, nitrogen different element with that oxygen, carbon different with the sulfur, hydrogen different with the chlorine, and hydrogen different with the bromine. Okay. So these type of molecules are called as heteronuclear diatomic molecules. Okay, friends. So these are the heteronuclear diatomic molecules. Okay, friends. So you think about these things. Now these are the very important concept. Okay, friends. But here one more. Now before going to our exact concept, so that is the bond formation. Now I will talk about that. Okay, now that is the first ionic bond formation is what, and next the covalent bond formation is what, and coordinate covalent bond formation is what. Now here ionic bond formation means now listen students, all of you, you look at the board, you think about these molecules. So this is the HCl molecule. Okay, now HCl molecule student. And you should think about this one. So this one the nitric oxide. Now tell me here what kind of atoms are existing in a molecule. Now hydrogen atom and the chlorine atom, nitrogen atom next to the oxygen atom. Now here, so if you take the H2 molecule and if you take the Cl2 molecule and if you take the F2 molecule, F2 molecule, Cl2 molecule, next to H2 molecule. So both these are single, that is same kind of atoms, diatomic molecule H2. Okay, the next one is that Cl2, two types, same kind of atom. Now here. Now in between, in case of chlorine and fluorine atom, there is no electronegativity difference. Okay, there is no size difference, there is no character difference, there is no electronic configuration difference. Both are the same. So that's why now these type of compounds does not undergo that of any type of ionic bond formation. Now here ionic concept means transfer of electrons from electropositive metal element to electronegative metal elements. Here transfer of electrons from electropositive metal to electronegative elements. Now in the periodic table, p block elements are considered as non-metal elements. They are ready to gain the electrons. First A and second A and the remaining metal elements are called as especially first A and second A group elements are called as metal elements. They are ready to lose the electrons. So these are the now the electropositive metal elements. So here the tendency of electropositive, the metals are ready to lose the electrons, non-metals are ready to gain the electrons. So in between ionic bond formation should be takes place. For example, NaCl molecule and next the MgCl2 molecule. Okay, students. Now the sodium, okay, first A group elements, chlorine, seventh A group elements. Okay, electropositive metal and next the electronegative metal. Okay, students. Now this one is the electropositive, next one is the electronegative metal elements. So that means in between sodium atom release the electrons, Cl atom gain the electrons. Okay, students. So these are the concept, and you should you must read the first two papers of that okay NCERT textbook in the chemical warning portion. Okay, thank you. I will continue next class.